Hello students and welcome back to Mechanical Engineering Practice and Graphics. This week we will be covering the chapter 14 of the book, working with drawing views, and this week you will learn how to do blueprints in Solidworks. First thing first, we are gonna verify our schedule as we always do every week. So we're in week 13. Uh, you will be doing the homework number 9 this week. And also you will be submitting the fifth and last part towards your final project. Now you will be working as a team, putting all the different parts together in an assembly file. And this is when you're going to realize that some of these parts will not fit together. So some of these parts will need some modifications, and that's fine. That's expected. That's why the final presentation is going to be in 2 weeks. Um, Remember also that next week we're going to have the fourth and last quiz of the semester. Usually the quiz are on Thursdays, so that will be next week. As I said, the final presentations are gonna be in 2 weeks. You will be presenting either your poster or your set of slides. And finally, the final exam is gonna be on the week of May 3 and 4, probably on Thursday of that week. I'm not sure if we're gonna proctor that one. Probably not. But for the final presentation, we're gonna meet on WebEx, where I usually hold my office hours at the same time of the office hours on Tuesday, probably. Next week, I will give you more details about that. So let's focus on what is gonna happen this week. This week, as I said, is the last part submission and the homework 9. You're almost done with the homeworks. So in this week, since you're gonna be uploading a blueprint from SolidWorks, the blueprint is going to work exactly the same as the assembly did for the last homework. The blueprint is going to refer to a part file that you have created. In this case, I'm going to provide the part for you, but still you will need to have the part and the blueprint in the same file. That's why you will be submitting either a compressed zip folder or a compressed RAR file. As usual, try to use the file naming convention that we've been using during the semester. And again, the homework is going to be due at Sunday midnight. Please don't wait until Sunday to start your homework, and please don't wait until the last hour to communicate your problems. I think I'm giving you plenty of time from Tuesday to Sunday, almost an entire week to do a homework that takes from half an hour to 1 hour. So please try to just organize yourself, organize your time to have these homeworks done earlier. That way, if you have questions, you can uh, communicate your questions to me and we can discuss this in normal office hours. Okay, so the homework for this week is gonna be this part. You already saw this part in a tutorial that I did a couple of weeks ago on how to do assembly files in SolidWorks. This week you will be focused only in one part, the vice body, and we're gonna learn how to do the blueprint for one of these parts. Again, the part will be provided, so if you go to Blackboard and then go to the link of the course, so courses, then our lab, here I'm gonna, okay, I have the student preview mode on, and you will have to go to content, scroll down, here you will find our folder. And then here you will find the instructions for this week. Again, you only have the homework and the fifth part for this week. I already uploaded sorry about that. I already uploaded the provided part and the slides. So you just have to click in this link and it will download. I already did, so it will download this part that I have here. Since I'm gonna show you how to do the blueprint, this blueprint, and you will be submitting the PDF of the blueprint, the SolidWorks drawing file, and the SolidWorks part file. So in this case, I'm gonna create a folder, let's call this in class tutorial. And in this folder, I'm gonna put the provided part. And here I'm gonna do the blueprint and the PDF. Okay, so let's go ahead and take a close look of the blueprint. So this is the format that SolidWorks has by default. And in this format, you will have this space to fill some information, as we will see in a second. And also, what I'm going to request from you in this blueprint is this isometric view, and then the three standard views, top, front, and side view. Also, one section view. In this case, I'm doing the section AA. I'm putting it here, section AA. And also a view in detail, as we have here in the bottom, the detail B. Okay, so I'm gonna open SolidWorks and I'm gonna create, in this case, we want a drawing, then click OK. And for this one, I'm gonna use the A2 landscape, this size for the sheet, and then click OK. So as you will see, A0 is the largest one, and as you increase the number, they become smaller and smaller. Here we have the width and the height. So for this homework, I'm going to request A2. I think that's enough space for doing what we have to do. And OK. And then I'm gonna browse here. So I have to change to week 13 in class tutorial. And this is the part. Open. And first I'm gonna start with the front view here. And then I'm gonna create the side view and the top view. And then I'm gonna click OK. Now, if I zoom here, you will see that I can modify the format by clicking here in the sheet format and then edit sheet format. And here we have the title, the drawing number, the scale, the material. So in this case, I'm gonna put here my name, or at least my initials, my ABC123, and the date. So today it's 4/12/21. Please do this as well. I will be creating that you are modifying the format and that you learn how to do this. So please put here your ABC123 and then the date on when you're doing the homework. Then you can click here in this icon and the format will be modified. Okay, so let's suppose that for whatever reason I didn't put the top view. That's not a problem. I'm gonna delete this one. You can select here the auxiliary view, sorry, the projected views. You select any main view and then you can drag the mouse and you can place the missing view. Also, I can define a auxiliary view by clicking here. Again, I select the front view. Sorry, not the auxiliary, the projected view. I'm gonna select again the front view, but this time I'm gonna put the isometric view here. Now, this one, I want this representation as a shaded with edges, something like this, and I can move this one around. Now look that if I put my mouse in this near any view, actually, I can start moving it. And if I move it, for example, the side view right and left, only that one is gonna move. But then if I move this one up and down, the front view, the side view will also be moved. Also, if I move the front view left and right, the top view will move along that one. Okay, so to create the section, we can click here in section view. And here in section, we have different cutting lines, as you see here. In this case, I'm gonna use the vertical cutting line. And I'm gonna select this center point here. I'm gonna click OK. And then I'm gonna place the section view around here. This one I can change the name, so I'm gonna put A in capital letter, and then OK. So here we have our section view. We have the side view, we have the front view, and the top view. Now for all of this, I want actually to be able to see the hidden lines. So with the hidden lines, I can see these holes underneath the vice body. And also I can see that this weird or Tetris shape goes all the way through the entire part, as we see here in the side view. Okay, now to do the detailed view, you can remove sections with this button, and with detailed view, I can draw some sort of circle here, like that, and then put that detail view down here, and here I can change the name, so I'm gonna put B, and then I can click OK. So as you see here, I have the B detail view, and here in the bottom I have the detail view. Okay, now we can add the dimensions, and to do so we go here to annotation, and then we click here in smart dimension. So my first recommendation to you is always try to give as much detail as you can. So imagine, for example, that you're gonna give this blueprint to a person that is gonna actually manufacture that part. That person needs all the geometric information that you can provide without being redundant. So for example, if I have here this diameter, I don't need to report it neither here, or here, because it is already clear that this hole has this diameter. A second suggestion is try to define diameters where the circle or the arc is. So I can define this diameter also here, but that would be a little bit confusing. It's better if I just draw the diameter in the circle. My other suggestion is that these are the three standard views. Try to have the space between the standard views as clean as possible. If you can avoid adding any kind of dimension there, that's better, because then you can see that each line in the top view should match a vertical or an edge in the front view, and the same happens for the side and the front view. I know that you are learning this in the lecture part, and so now try to have this space clean of any kind of dimension. All right, so the objective of this homework is to replicate this blueprint. I'm going to actually do it, so you will only have to follow the steps on this tutorial uh, to complete this homework. Okay, so with the Smart Dimension tool, I'm gonna actually start on the top view. I'm gonna go up here, and then we have these 3 dimensions here on the top. So I'm gonna start by selecting this edge and then the circle. And then I can select this half moon that we have here, half a circle, and that will place the dimension on top of this drawing. If I look what happens if I select the one in the bottom, that will put the dimension down. Also, you can select to place the dimension as you prefer, also higher or down. But doing it with this control, it has by default this distance, which is like a standard distance. So it's better if you just use the either the half or quarter circle that Solidworks uh, gives you the option to. Okay, now we have these other 3 dimensions here. Now I can also move the number outside the dimension, and that will still be clear, but it's better if you just have it inside the dimension. Also, you can modify the number of decimal positions that you have in your dimension by selecting the dimension, and then here in tolerance and precision, you can define none, and that will take out all the decimal points whenever you are presenting blueprints as a professional. As you see here, I also have the center lines for the circles. You can do so by selecting this option here, center mark, and then you select the circles. And I'm gonna do that also. Well, this one already has the center mark, but this one doesn't. So I'm gonna put that one there. And that's it. Also remember that any cylindrical hole should have an axis line or a center line that you can add by clicking here in center line. And in this case, it will be, let me see, we have this one and this one. So we have that center line there. And also we have this one and this one. We have this center line here. Also here we have some cylinders, some hidden cylinders here and here, and also in this section view. Also here and here and here. So with that, I think it's a little bit more clear that those are cylinders. All of these center lines are showing exactly that. Then what I'm gonna do is, I already have these center lines and these center marks. I'm gonna move to the front view and start adding these dimensions. So the trick here is to add the minimum necessary dimensions that can explain the entire geometry. If you ask me what is the criteria to know if I should put the dimension here or on the top or maybe in a different view, that's your judgment as an engineer. So you will develop that with time, I guess. There is not like a proper rule to define where to put any dimension. There are rules on where not to put the dimensions. Okay, now I'm gonna do this distance here from this edge, sorry, from this edge to this point down. I forgot to mention too that you should try, I'm gonna redo this one. You should try avoiding crossing. So if, for example, I leave this dimension here, you will see that these auxiliary lines for the dimensions are crossing, and that can create confusion when you print this. So you should avoid always to have this kind of intersection between these auxiliary lines, this horizontal line and this vertical line. Instead, it is better to have the dimension down in the bottom. That way I can avoid this intersection here. Okay, now I also have this other dimension here in the bottom. Since this 10 is being overwritten on top of an arrow, I prefer moving this one to the side. That way it can be more clear. Also, let me see if I can make this one smaller. No, so let's just leave it that way. I was just trying to avoid this intersection here, but that's fine. And then I'm gonna add this 22 on the side here. Maybe that's too confusing. Yeah. Okay, and then for the side view, we have all of this information. Seems a little bit chaotic there. But the point of maybe adding most of the geometric information in this view can help the person maybe modeling this part, knowing that maybe they should start with this view because it has most of the geometric information here. So let's start with this circle. And then this arc. Of course, this is centered, so maybe, yeah. Okay, now I'm gonna add this vertical distance. And then this one here. Then this height, 7 millimeters. And the entire height. Okay, now all of this. And also this one. Okay, I think that's it for this view, and we're gonna move to the section view. Here we have this angle, very important, and we have this fillet here. Now, this fillet, of course, there is one at this side and one at the other side, but since this is very symmetric, I can just explode that and define here 2x radius 3, and then I'm gonna reduce that. I can write here the 2x, and automatically that will be in my dimension, like this. So no, don't worry if you see that in my blueprint I have some lines are just straight lines, and in my case I have like an angle here. Those are just equivalent, are just different styles of writing the dimension, but they are equivalent. The important thing here is that you learn how to add dimensions, how to add the center lines, how to add the center marks in SolidWorks, and then changing those little details is just a matter of playing with the dimension representation and so. Okay. If you, for whatever reason, need to add geometric tolerances, adding uh, additional information, there are some other things like surface finish when you have welding procedures, weld symbols. You can also define here these our traditional dimensions for holes, like in this one. So I can maybe in this view, let me see. Yeah, I can define the angle, sorry, the diameter and the depth of this hole, and that there are four of those here, or I can also do it here, probably. Let me see. No, it has to be with a circle, so it will have to be like this one. So I can define that hole like this, or I can do, I can explain the geometry here. Maybe if I move this detail here to the top, and then add this size here, automatically it is recognizing that it's a diameter. Also, I can define this height, and then I can also define this angle here. Or actually I should define this angle. Okay. And that would be like what we have here. Again, since in this case, this same hole is used 4 times, so you can just, let me select this vertical dimension here as well. And here we can click 4x, and then we have this detailed information, which is also found here. Okay, so this is our blueprint. I will say that's finished. If you follow each of the steps that I have been doing, then you should be good. Then here we're gonna click in Save As. And here I'm gonna use my L3 ABC123. This is my ABC123. And then homework 9. And as you see, the file extension for this one will be SLDDRW, SolidWorks Drawing. I can save this. Components document must be saved. Okay, I'm gonna save everything. That is saving the part as well. And then I'm gonna close this. If for whatever reason I need to continue working on that blueprint, I can always open that file that I created, the Solidworks drawing. As long as it has the same part in the same folder, that should work, or at least in the same location where you initially saved the drawing. As you see, it is loading the components and verifying everything. If for whatever reason I move the part to a different folder, this file might stop working, and then we will have problems because I will not be able to grade your homework. That's why I need you to submit the entire folder. Then to create, the PDF, you can also save as this document with a different file extension. And here we have Adobe Portable Document Format. That's the PDF. You can use the same name, that's fine. And then save. And if I go to that folder, you will see here that I have my PDF, which I can open now. And here we will have our blueprint. Again, here we have our ABC123 and the date in which this was created, the file name, the material, the size of the format, and some more information that you can modify. And that's it for this homework. Now, for you to compress this folder, if you're using Windows or even in the VDI, so the folder that I'm gonna compress is this in class tutorial. I just have to right click on that folder and then I can click in send to, and here the second option, it says compressed zipped folder, and I can change the name if I want. And this is the file in class tutorial.zip. This is gonna be the file that I'm gonna submit to Blackboard. So I will have to go to content, submit homework here, homework 9, browse local files, in class tutorial. If you need to write anything, you can do so and then submit. And that should be it. All right. Once again, thank you for watching this video. Remember that you have the 5th part this week. And next week, we're going to have the last homework. We have the quiz number 4 on Thursday. Let me see. Yeah, let's do that on Thursday next week. And that you should be working now on your final assembly for the final presentation. Thank you and have a good day.